Hi, everyone, and welcome. I'm Martin Wennerblom, Product and Marketing Director at InMotion Technologies, part of Sappi Group. I'm very pleased to welcome you to this session here at the FOE 2026 conference. Please note that this session is being recorded and will be available to watch on demand after the event. If you have any questions during the presentation, please use the Q&A tab. You will find it to the right of your screen. All questions will be sent privately and addressed at the end of the session if time allows. With that, it's my pleasure to introduce our speaker and a session titled From Custom Lithium Technology to Predictive Electrification, Lessons Learned from a Global AGV, LGV Deployment with E80 Group. Today, we are joined by Marco Rigi. Marco graduated as an electronics technician and later earned a degree in economics and management. From an early age, he began working in his family company, specialized in high-frequency battery chargers, where he developed a strong passion for both entrepreneurship and energy technologies. As the CEO and founder, Marco leads the company's growth and long-term strategy with a highly consultative and tailor-made approach, supporting OEMs and system integrators throughout the entire electrification journey, from early design phases all the way to serious production. Marco, welcome. And with that, please take it away.
Thank you so much, Martin, for this wonderful introduction. It's truly a pleasure to be here today, and I'd like to thank the Sappi Group for the invitation and the opportunity to share our experience. It's also special for me, both because we collaborate closely with Sappi in many electrification projects, and because, as you told, I'm took the very first step in Zion, part of Sappi Group. Okay. I think we can start with the main topic. Today, I would like to share our experience on bringing lithium battery technology into the LGV world. Just a couple of slides to explain who is Flash Battery. I'm Marco Righi, as explained before. Our company started in 2012 and now is an Italian leader in the manufacturing of lithium batteries, from startup to global company, because now we have our headquarters here in Italy, and a subsidiary in US, mainly for after-sales support of our customer. And we have a lot of partners and dealers across Europe to be closer with the customer. But what we do? We produce custom battery solution for industrial electrification OEMs. On this slide on the left, you can see the industry that we serve, starting from the AGV, LGV, that is the main topic of today. But we are also working for GSE, AVP, cranes, special machinery, electric vehicles like last mile delivery, but components with automotive conformity, construction, cleaning, and agriculture, that we also expect for these three segments the next year are able to grow. How we work? We source obviously the lithium cells from the biggest producers in the world, and we assemble all in-house, using also our last big investments. It is our automated production line with laser welding technology to assemble the module and the cells. But since the beginning, we started with the idea to keep all the knowledge in-house. We have the knowledge, and we developed our BMS, hardware, firmware, software developments, mechanical and electrical customization. We follow the customer from the first prototype to the industrialization of the serial production. And also, when after the shipping of our batteries, we continue to follow our products for all their life through our data center. It's a portal where we do the predictive maintenance. Just a couple of numbers. More than 30,000 batteries produced and on the field, more than 800 custom models developed, and 550 megawatt hour of battery installed in many types of vehicle. Today, in this presentation, it's really important also to introduce our partner, E80 Group. We begin our working together since 2013, and they become as a strategic partner in 2015. We co-design the solution as a battery, but also part of the LGVs. And today we have more than 10,000 AGVs worldwide equipped by flash battery technology. In the picture with me, Enrico Grassi is the chairman of E80 Group. To give you a better understanding of this application, let's take a look at a short video showing the complete solution in action across some of our plants worldwide. Okay, really wonderful from my point of view, these plans. Okay, the agenda of this part. First of all, we take a look about the logistics sector requirements. Then we saw the integrated solution developments. And then key topic that are safety, long life, charging time and flexibility, and predictive maintenance and remote control. Starting from the requirements of the AGV and LGV sector needs, first, it's crucial, safety as a core requirement. Second, 24 hours, 7 days a week, operational with minimal charging windows. Long battery life and continuous cycling, fast and opportunistic charging, and minimizing balancing time to maximize operating hours. We start from the safety, fundamental, especially in environments with flammable materials like tissue, for example. We have a lot of special plants, but the safety is every time at the number one, and we must ensure thermal stability under stress and controlled reaction in any condition. 24/7 automated logistics require continuous operation. We are dealing with AGVs that have really high cost, and we need to minimize the downtime as much as possible. In our case, it's far better to have frequent and fast charging opportunities rather than longer charging session. A battery can be fully discharged in this segment 3 or 4 times a day by being fully. If we compare it with the automotive, that normally a battery was used 20-30% a day, in this case, we are using 300-400% a day of the capacity. It means a completely different world, and in terms of reliability and stress, that this battery have to support. And this point will be connected with the next point, the long life, because with this stress on the battery, the lifespan it's really important. Also because a long life reduce also the total cost of ownership, and it's really important the reliability of the battery packs. Last point, fast charge. No, sorry, it's the fourth point. Fast charging to sustain continuous cycles. Obviously, if we need to stop the vehicle as less as possible to have the maximum operation in the mission that the LGVs has, we need to charge faster. Also in the video, you saw 2 type of charging method. One is by contact, by copper contact, and one is induction. But it's really important to do not stress too much the battery, but also to be quicker in the charging time. Last requirement is the balancing time, one of the most critical constraints in automated logistics, especially with some chemistry, and we will see it. Traditional lithium system require long equalization phases. It means to have a minimum 10-hour equalization phase every week, and most of these fleets cannot wait. They cannot remain with one LGV out for 10-15 hours. Okay. Integration solution. We integrated the batteries into the LGVs and vice versa. Unified ecosystem where the battery and the vehicle and software operates as a single system. Is not a battery pack installed in an LGV, as normally happen for normal lift truck. The battery and the lift truck just exchange the basic information to work together, but in this case is something that is completely different. We started with the mechanical design and safety integration. We have a range of product designed for E80 group from 5 kilowatt hours up to 28 kilowatt hours. Full internal know-how in every components in the battery. Obviously not the cells, because the cells there's no production at the moment in Europe stable for this kind of cells. And also another important point is the study of the cooling and the heating flows, and not at battery level, but the system level. Okay, because we can have a wonderful battery with perfect cooling, but fitted in a closer box doesn't have any type of results. We need to study the complete solution. And we do the same for the safety components. We are always integrating new feature to be better and predictable. In this case, the last introduction is the gas detection system. We explain it in the next slide. After the mechanical design, we have the hardware and software integration. as explained, we have a patented BMS, our own BMS design for these specific needs. And also we have different level of communication between the system. The battery has a first integration through CAN bus line with the LGVs, but also the battery is continuously exchanging data with the LGV manager, that is the manager of the whole plant, because we have to take decision based on the situation of the plant, not only of a single components. Okay, it means we have this second level, and we have also a third level. Is the and also for to be able to do that, we specific developed hardware and software devices to create a communication between the battery to the cloud. You have to imagine that this big multinational company that are buying these with these LGVs doesn't are really want to keep the safety of the network, and also it's really complicated to send out information from the plant. We studied as a reliable solution to allow us to send information daily to our data center, and on that data center we do the predictive maintenance, but we will see in another slide. As I told you a few seconds ago, the decision are not in charge to a single battery or single LGVs, but we collect all the information, and also the charging algorithm are at high level, because we need to understand the situation of the plant. If we have a low efficiency moment, we can have more LGVs in charge, or we can anticipate some charging strategy to be ready with most of the LGVs fully charged when the efficiency of the plant is increasing for a peak of production, for example. Okay, it's completely flexible. Starting to answer to the needs of the market, the safety is really crucial. The safety is composed by three main key elements. The first one is the cells. What kind of cells and chemistry we are using. Battery architecture, how the battery is assembled, and battery electronic, the BMS. Starting from the first one, safety of the chemistry. This is a nail penetration test. We are penetrating two different type of cells. On the right, we have a NMC cells with a really high energy density. On the left, we have an LFP cells, the one that we are using every day. You can see immediately the difference in the reaction. Okay, on the right, already the cells catch fire. This cells is wasting the energy so fast. On the left, in a few seconds, the safety valve open. The white smoke is the electrolyte, and the gas is released, but the temperature is still below 60 degrees. So it's increasing, but really, really low. Is different the release of the energy, because during the nail penetration, it's a short circuit. It's the worst case of short circuit that we can have. If we can keep under control the safety in this phase, we are in a really good condition to start to assemble the pack. We perform this test. It's really difficult to penetrate a battery pack complete, to be honest. But this is a simulation of the worst case on the field. Single cells that for a problem during the construction goes in short circuit alone by themselves. In this case, one cells here on the left, the red one, doesn't exceed 144 degrees. It means is not able to propagate the thermal runaway to the closest cells. The example on the right, the NMC, in this case, when it catch fire, ignite also the closed cells, and we have a domino effect. Now we are back to 35 degrees. And this is just to explain that it's really important to choose the right chemistry. We can have additional consideration. Safety, we already saw LFP, lithium iron phosphate, is better than nickel, manganese, and cobalt. Same things for the life cycles. Energy density is better than NMC. But for this type of vehicle, LGV, AGVs, and also lift truck, is not needed a really high energy density. It means the LFP is more than enough. Also, the cost is better. There are less critical material in the LFP. This is why also Flash Battery selected the LFP chemistry because it's stable and safe. And also because the safety and the stability of the LFP outweigh the balancing advantage of the NMC, making LFP most reliable choice. Second point, the architecture. It's really important also how the battery is assembled. Remember that less cells in parallel means higher safety. In this small video on the right, we see a problem on a cylindrical cells with a lot of cells directly connected in parallel. If that cells has a problem, all the others start to provide energy to the cells with the problem. And one cells have to waste the energy of 50, 100 cells. It means that we cannot control the temperature of that single cells. In the industrial application, we prefer to use bigger cells, and we produce pack with maximum 4 cells in parallel. But now we can cover the 95% of the needs with only 2 cells in parallel. For example, in the fleet of E80, we have maximum 2 cells in parallel. Third point, important point of the safety, electronics. The BMS must prevent damage, yes. How it can do it? For us, one of the most important things is to monitor the right temperature, to have a wide analysis of the thermal condition of the battery. In a 51.2 volts battery packs, we have over 32 thermal sensor on the cells and over 40 thermal sensor in total in the battery. It means that we can feel every hot point that could be created. If you stop to charge and discharge while the problem is starting, you can keep all under control. Because also on the connection, if we have, for a problem during the production or during the battery life, one bolt will be not tightened well, that's a hot point, and it's really difficult to feel it if you have a sensor maybe in air at 20-30 centimeter of distance. If we have on the bus bar, we can feel exactly the temperature and prevent possible problems. Another topic, but is also a requirements of many regulation, is the redundant system, to have a high safety level of VMS with a high security level. Back to the gas detection technology. This is an introduction of the last years, and help us to identify early some anomalies and enable preventive action. I go directly in the next slide because it's really useful. In this graph, it's a real case of a test that is a battery pack where we overcharged a single cells to start the thermal runaway of a single cells. The red curve is the cell's temperature that we normally monitor. The green line is the gas detection system. When it goes to 100, it means that the gas sensor detected the gas in it. The battery packs normally could operate up to 60 degrees. It means if we saw a temperature that increase, we cannot set up an alarm at 35, 40 degrees. It means we need to reach or to see a big increasing of temperature. It means we have to wait. The electronics without a gas sensor is able to identify the thermal runaway 12 minutes later than a battery with the gas detection system in it. When the safety valve of a single cells open, immediately we feel it, and we can set up the safety procedures. Also, in this case, the safety procedure was created with the E80, considering the specific environments. We have a specific area where the LGVs could move and stay in safety condition. Okay, fourth point, long life. We already anticipated that the LFP has a better lifespan than NMC. In this graph, we reported also an additional chemistry, LTO, lithium titanate. But lithium titanate has a problem because it's a niche. It's a niche production. Just a few producers have it in portfolio because it has a really low energy density. It's not fine for automotive and this kind of application. We are testing on the field. We have a batch of LTO in production, but is not our main product for the AGVs. After the LTO, the better lifespan is the LFP. Okay, this is why we choose the LFP. Thermal management. It's also important to have a long life to keep the battery in the right temperature range. AGVs and LGVs sometimes the environments where they are working could be also really with wide operation temperature. We work in a cold chamber at less 30, less 25 degrees. In this case, we have a specific battery studied for this temperature. And also we have a plant in Mexico or in a really hot country where we can have also 50 degrees or 55 ambient for some peak. We studied an integrated cooling and heating system to perform properly in all of this condition. Obviously, as discussed before, the integration with the LGV, it's a must, and it's really important because we cannot divide the cooling solution between battery and LGVs. Have to be one system. This is why we wrote suitable for cold storage application, and also battery cooling might be designed as an integrated system. Okay. Next, charging time and flexibility. I have to speak more deeply on the BMS to explain this point, because traditional BMS, traditional batteries, normally has passive only or active only balancing with low power, and it takes long balancing time, from 8 to 12, sometimes 15 hours. And also, they are not able, because if we are using low power, if I do the balancing also during discharge, I'm not really effective. Someone have only partial temperature control. Almost nobody has a predictive system. Remote monitoring, yes, but not predictive. And without a right predictive system, the cost for the maintenance and sometimes for remote update, if are needed, are costing a lot. What we studied, the flash battery solution, we have a high power active and passive balancing time, short and predictable charging time. For cycling application, we have a balancing time. It means to reach 100% of the state of charge with all the cells completely balanced in less than 30 minutes for cycling application. We can actively support the weaker cells during the discharge. Again, temperature control is really important, but we can skip for the moment. We are monitoring the internal resistance of each single cells to have an advanced state of health evaluation. This is really important for the prediction and to identify the end of life. Remote monitoring with predictive analysis, and FOTA, the firmware over the air update possibilities. The system is patented, but which is the benefit for the AGV users, in this case E80 group? That we can perform not a fully charged every week, but every 2 or 3 weeks. It means we do not need to stop every weeks for 10-15 hours each single LGVs to perform the balancing. And after 3 weeks, when we perform the balancing, we have an average time of balancing of 90 minutes. It means 90 minutes every 3 weeks. This allowed 57 hours of additional operation per month, compared to a conventional LFP battery with the traditional systems. Okay, 57 hours. It's really a long time, long period. If you consider that the AGVs and LGVs has a really high cost, we can make also calculation how is the cost of these 57 hours. If we there is the possibility also with different chemistry to reduce the balancing time, but different chemistry, it means NMC, and it means all the problems that you saw in the safety and lifespan consideration. Okay, predictive maintenance and remote control. That's a point where we are investing a lot. The system enables continuous data exchange between battery fleet and the LGV control software. Real-time data are really important, but I want to make a focus on a point. A lot of producers say that they have the remote controls, but the remote control is useful, is not predictive, because normally I feel when the customer feel the problem. In flash battery, we started in 2014 to develop something different. Our data center is collecting all this data, is analyzing all the information from the battery, and is looking for a potential problem that can come up in months, and we want to prevent it. This is why we have this solution with the logger in the plant that collect all the information from the battery and securely we have this transmission to the data center and allow to continuous monitor and predictive maintenance. 24/7 control. The predictive maintenance also send alert to our after sale support. Sometimes also to the final customer, because if the problem is related to a battery usage and not to the battery itself, we can also inform the customer directly. I give you an example. In the past, we had LGVs in a climate chamber, and every weekend, the customer was turning off the LGVs inside the climate chamber. It means every weekend they were freezing LGVs and batteries at less 25 degrees because they never know that they can reduce the battery life. We feel it, we inform the customer, and now they leave during the weekend the vehicle on and the battery in the LGV remain at the right temperature. That's an example of predictive maintenance with information directly to the final customer. We can control obviously the battery and perform the over-the-air update if needed, but also we can continuously analyze the performance to have better battery in the future, but better battery, better plants with higher efficiency also to the system level. Last introduction in the data center was the machine learning and some AI algorithm to be able to analyze better our data. The battery pack is really complicated, especially if we analyze the chemistry. There's a lot of potential variation, and we started with simple alert. If the temperature increase over threshold, send me an alert. But now what we would like to do is to create and study more complicated relation between the performance of the battery pack and the condition where they are working. For example, to have a digital twin of the battery and the continuous learning based on the real field data. Okay, we are almost in the end. I show you a video that represent the complete integration with E80.
The E80 Group presents the benefits of the innovative system for AGVs with lithium batteries and induction charging. Since 2013, all the automated and laser-guided vehicles that we have installed around the world have been equipped with the latest generation lithium batteries developed by Flash Battery. The advantages are several. The chemistry mainly used is LFP, the most stable on the market, which combined with proprietary electronics and careful design ensures maximum battery safety. Lithium batteries are not subject to the release of gases during recharging, so fume extraction systems and water demineralization wells are no longer needed. Neither are special charging rooms. Every LGV has only one battery, thus eliminating all battery changing systems. This represents also a major saving in terms of space, as you see from the layouts of one of our clients' plant before and after the conversion of their LGVs to lithium batteries. Flash Battery batteries boast an energy efficiency of more than 96% and guarantee balancing speeds 20 times faster than other lithium batteries on the market. At 10% charge, LGVs can continue operating for up to 90 minutes and then recharge in only 5 minutes thanks to the induction charging technology. This mini charge-discharge extends the life of the battery. Recharge times are controlled by a software to improve system efficiency, guaranteeing an increase in LGV availability. The battery was developed to meet the specific needs of LGVs with complete hardware and software integration. Smile 80 determines the best timing and duration of each individual recharge to support production peaks, increasing plant efficiency. to their thermal insulation, these lithium batteries work in all ambient conditions above -30°C, while a built-in cooler permits functioning at temperatures up to +45°C. Batteries don't require on-site maintenance. Finally, thanks to Flash Battery data center software, we undertake the daily remote monitoring of all lithium batteries installed in different systems and arrange preventive maintenance if needed, drastically reducing downtimes. The batteries of our AGVs and LGVs can also be recharged through induction technology. The induction charging system for AGVs provides significant advantages in terms of reliability. Thanks to wireless technology, this type of charging eliminates the possibility of sparks and electrical arcs, improving safety standards. Compared with conventional systems, induction charging eliminates routine maintenance and reduces charging time by 10% because it has no moving parts. Flash battery batteries and induction charging mark a decisive innovation and increase the overall performance of smart factories. Powering your evolution.
Okay, just in the end, electrification is not a component, it's a system. I want to leave with just three phrases. Every application is different, no standard solution works. Battery performance depends on integration, not just a chemistry. And the data is the key to making electrification reliable over the time and to continuously improving the performance of the system. Thank you. I'm completely available if there are questions.
Good. Thank you so much, Marco, for this insightful presentation. And we
Thank
have
you.
some questions from the floor. And I can remind everyone that you can still put in questions. It's on the right side of the screen in this platform. So please do that. The first question we have is regarding LTO batteries. So
Yes.
looking at the safety and future use, how do you see LTO batteries' role in the future?
It's we started to use 5-6 years ago, but the problem is that we cannot be so reliable if there are on the market only two producers, and this is what I'm feeling. It's a niche, it's an interesting technology, but the low energy density is limiting too much their application, because it's fine for AGVs, but it's a niche of the niche.
Oh, okay.
Yes. For automotive buses or stuff like that, it's really difficult because it's expensive and really low energy density.
Okay. Thank you. We have some more as well. So let's take the next one here. How difficult is it to integrate your solution into a vehicle? You mentioned here at the end of the presentation that there are no standard vehicles, but I guess you can't. Is it even possible to build a standard, or how complicated is it?
But someone have to adapt something. Okay, the standard in the industrial application, from my point of view, doesn't exist. If both parties are able to cooperate and comes each other close to the other one, it's better to play. No, I think it's better to have a partner that is working with you as are looking for the final target. If I give you this and you have to take care about all the rest, I can do only this. I think it's difficult to increase the added value on the final solution. This is why I think it's easy to integrate, but at the beginning, what we are doing is the big analysis of the application. We need to really understand the needs.
And also be part of that initially. I mean, with the physical space in the vehicle and all of that, I guess that's a big success factor for any project.
Yeah, absolutely. Yeah, obviously, the mechanical it's easy to think, not all the times to do, but after the mechanical aspect, there's the electronics aspect, but also really what is the challenge most of the time is to understand exactly what's the expectation of the machine, of the customer, what's in the whole usage of the vehicle.
Yeah. Good. Thank you. And if we say here, the end of life, you mentioned that you have predictability on your batteries. So your data center is calculating that on a daily basis, basically. But how can you define the end of life on a battery? And I mean, that seems to be very hard to predict, but
yes, it's really hard to predict, but we are working hard on that point because it's really important. When now, for example, only for E80, we have 10,000 batteries on the field, and we cannot wait that the battery died because it means we stop vehicles. We don't want downtime, and also we don't want to waste the battery with potential in it. And we are investing on the algorithm, and with we started 2 years ago with an analysis of the internal resistance of each single cells.
Wow.
In 51 volts battery pack, we have 16 cells in series, and we are able to analyze the internal resistance. It means we can have a long prediction with less reliability based on all our historical information. We calculate the state of health, but also we have a short-term analysis, really reliable based on the internal resistance.
Okay. So you have a method for that to make sure that you are covered. Good. We have another question here. May all lithium chemistries be recharged by inductive technology?
Yes, but I can say not all the applications are requiring induction. Okay, there are some advantages for some niche of market, but for probably I can say that 80% of our battery are charged by traditional charging method. Because where there are specific requirements also in terms of safety, for example, tissue plants where we have a lot of dust of paper that is flammable, to avoid possible spark in the connection. It's an advantage. For others, it's not completely an advantage. It depends. But yes, theoretically, all the lithium technology could be charged by induction.
A follow-up question from the same person is, which is the current kilowatt price and discrepancy one to the other of mentioning lithium chemistries? So
on the market, there are really a wide range of prices. It's possible to find products that are coming from China from less than 200 euros per kilowatt hours up to 500. If we compare just NMC to LFP, we are speaking about 10-20% of difference, no more than that. If we are speaking from LFP to LTO, it's really huge the difference because 3-4 times higher.
Okay, that region.
Yeah.
I mean, the price seems to be volatile, especially under these conditions right now.
Yeah, it's also it depends of the dimension of the battery because obviously biggest is the battery. Also in our cases, better cost for kilowatt hours we have. For smallest battery, if you provide a lot of things regarding BMS, safety, or this part, you increase the cost per kilowatt hours. For biggest battery pack, also these components are not affecting the price.
Oh, okay, because well, the bigger battery then the
Yes.
BMS cost is smaller in comparison. Yeah. And one more question here is what are the 3 key parameters to think about when designing the battery solution into the vehicle? So
But we said it a bit before. Obviously, the beginning we evaluate mechanical, electronics needs in terms of consumption, charging, and etc. But yeah, the most important things is to understand exactly what are the expectation of the vehicle and in all their special action that they have to do. So at the beginning, it normally looks really easy, but while we are doing the battery and doing the commissioning, we saw that there are a lot of special things that at the beginning were not present.
So, yeah, okay, good. Thank you for that. And we have covered the questions from audience.
Thanks.
So,
Thanks to
do you
you.
want to say some closing words before we stop this broadcast?
No, it was really a pleasure to be here and to be part of this speech and provide our experience on this market. Thank you.
And thank you so much for being part of this conference. Thank you.
See you soon. Bye, Martin. Bye.
Bye-bye.